Okay. Hey guys. Today we are gonna learn about the internal structure of Earth. Okay. In general, how we define the internal structure of Earth? First thing, what we have to do, we have to have a P wave and S wave. Okay. So internal structure revealed by P wave and S wave pass through the Earth in response to earthquake. So we are defining the internal structure of Earth with the help of the P wave and S wave. P wave is a compressional wave, S wave is a shear wave. Okay. Now this seismic wave. Okay. This seismic velocity vary with depth, temperature, mineralogy, chemical composition, degree of partial melting. Okay. Seismic discontinuity divide the Earth into majorly three parts: crust, mantle, and core. Okay. In crust there is a lithosphere. Okay. In mantle there is a upper mantle, there is a lower mantle. In core there is a outer core, there is a inner core. Okay. This discontinuity reflects in composition or phase or both. So this is a chart. In a left side we can see this P wave. Okay, this P wave start increasing its velocity in crust, and there is a low velocity zone, it decreases velocity. Why? Because a low velocity zone, it means it's a state that the low velocity means seismic velocity decreases in this particular zone. Okay, so this decrease in particular zone, this velocity decrease in particular low velocity zone. Now a P velocity start steadily increase up to 760 kilometer. Okay, up to the upper mantle. Now steadily increase in the lower mantle and abruptly decrease at the core mantle boundary. Okay, and further steadily increase in the outer core. Okay, so what it shows? It shows that there is a abruptly decrease in velocity at the point of core mantle boundary, shows that the outer core must be a liquid. Okay, and a S wave velocity steadily increases from crust to the upper mantle, lower mantle, and abruptly decrease. And we have not seen S wave velocity in outer core. Okay, so what we find here, S wave does not pass through the outer core, means it does not pass to the liquid. Okay, now in inner core we found S wave and P wave both. So inner core must be a solid. Okay, now from this particular graph we found that this internal structure of Earth. So first, crust, upper portion of the Earth. Okay, known as crust. It in continental it extended up to 30 to 40 kilometer. Okay, and in oceanic crust it extended up to 10 kilometer. Okay, below the crust there is a lithosphere, there is solid portion, and so this is a lithosphere. Okay, and we found that there is a Mohoric discontinuity. There is a Mohoric discontinuity region where there is a Mohoric discontinuity below the crust. Okay, and there is a lithosphere. It has thickness up to 50 to 300 kilometer and consists of a crust and upper mantle. below the lithosphere there is a asthenosphere extending from the base of lithosphere to 660 km discontinuity and is by comparison a weak layer that readily deforms by creep. So asthenosphere is a partial melted portion, okay, a plate which travel on the asthenosphere, okay. So we see a plate tectonics, okay. uh, Asthenosphere is like a ocean to the plate, okay. At the top of the asthenosphere, region of the low velocity zone occurs and is from 50 to 100 km thick. Okay, so this is the asthenosphere, and now we are going to study about the upper mantle. Okay, so what is upper mantle? It extends from the moho means Mohoric discontinuity to 660 km discontinuity, includes the lower part of lithosphere and upper part of asthenosphere. The region 410 km to 660 km discontinuity is known as the transition zone. Now there is a two solid state transformation in this particular transition zone. First is from olivine to westlight at 410 km and at 660 km transitions from spinel to perscosite plus magnesio-wüstite. Okay, now we're going to learn about the lower mantle. 660 km to 2900 km discontinuity at core mantle boundary, constant increase in velocity and density in response to increase in pressure. Okay, so we see that there's a steadily increase in the lower mantle. Okay, and between the lower mantle and outer core we found a Gutenberg discontinuity. Okay, and at the core mantle boundary a seismic velocity abruptly decrease, okay, and steadily increase in the outer core. Okay, between the outer core and inner core we found Lyman discontinuity. Okay, so we're going to learn about the outer core. So in outer core I was said that not transmission of the S wave and is interpreted to be liquid, extends from 2900 km to 5200 km, abrupt reduction in velocity. Okay, we can see in this graph about this. Okay, now inner core extend from 2500 km to the center of the earth, which means 6371 km, very low velocity suggesting that it is near a melting point. Okay, and inner core is a solid. Okay, it consists of nickel and iron. Okay, and core is believed to consist of iron and nickel similar to iron meteorites. So it will also give us the idea about the origin of earth. Okay, so you have to remember this particular graph, depth versus velocity graph, and this. Okay, so you can easily understand the internal structure of earth from these two figures only. You just remember these two figures and note down these two figures. Okay, thank you very much. Make sure you subscribe to my channel and press the bell icon for all the latest update. Thank you.